All right, so the first example that I wanted to show you was just a point, very simple version of how Grasshopper works. All right, so I've pulled up Rhino and Grasshopper here, and I have just a really simple definition I want to run through really quickly. This construct point here is what makes a point. So this is the like a parameter, right? So this is just a data point of 4. And if I turn this guy on, it's unpreviewed right now, but if I preview it, you see that I get this point coming out here. And if I move this point around, right, it's going to move it in a 45-degree because it's doing the x and y coordinate. The z coordinate is at 0. And then if you go in and start to move a point around, so if I come over into Rhino and I put a point in here, right, and then I take this guy and I set one point, right? Let's go ahead and turn this guy off. And then let's preview this move, right? You can start to see that point move from its original direction in the unit factor z. So we're actually moving it in the unit factor z. We can also move it in the unit factor y, which actually moves it right in that same position that the other point is. So if I turn this guy on, right, it's slightly behind it because the point itself, right? Let's turn the ortho off. The point was coming from the same place, right? Then you're going to get that same kind of movement. They're going to be in exactly the same place. All right, so let's go ahead and those guys off. And then over here, we just have that sort of idea of the squares creating a series of points, right? So if I come in and preview this, it creates a grid, and it gives me the points for that grid, and I can actually come in and put circles on those points, right? And control the radius of those circles. So think of it as an open command string, right? So we have control of the size of the grid, right, and the size of the circle. So it's more about the input and the output, right? So let's go ahead and close those guys off. And then this very last one is sort of interesting. I'm going to go ahead and pull out a panel here. Put that in there. And let's zoom out on this. So what this series does, if you take a look at it, it comes in, it starts at 0. It has 13 and it counts at 5. So if you do 5 times 13, that's 60. If I were to start to adjust these, you're going to see the numbers change based on the adjustment. Now, what that does is it creates a series of numbers. And what I'm going to do is cross-reference those numbers, and it's going to construct a point grid. So if I go to preview, I now have this point grid that's three-dimensional, right? So if I come in and start adjusting that, there's the spacing, and there's the actual number, right? So you can start to go in and construct sort of these fields of organization, which work really well. And it's just a different way of thinking. Like, I mean, it's at this point, if you wanted to, right, you could actually come in and put a circle on every one of these planes, right? And now I've got circles on every single one of those planes, right? So there's all these sort of idea of having these packages of things that do things, and then you can plug things in, and it's very dynamic. All right, so the next thing I wanted to show you was how you can think differently, because it's really just the manipulation of points, but thinking about how you can construct a form in a way that you may not have originally thought about. So here's a definition. Again, this is in Dynamo, but I'll show it to you in Grasshopper here in just a second, that takes brightness information and translates it into form, so you can just replace the image and it'll give you a new form. So let's go ahead and take a look at that one. Okay, so here is the image definition, the sort of image sampler. I have it all sort of unpreviewed so you can't see it. But what we have basically is a surface. So if we preview that surface, you're going to see it. showing up there, right? So it's just a flat surface. And then what comes in and happens here is this divide surface goes through and divides it. So if you look at the points here, whoops, sorry, let's do a panel. And you plug the points in, you're going to see it's just going to give you a grid of points, right? And what what this does right here is it goes and samples an image, and it takes these parameters, right, which sort of reevaluate that surface to a 1 and places a parameter at each point between 0 and 1 in the x and y. And so these parameters go in and sample this guy, right, at each one. So if I preview this, you'll see we've got a grid across our surface, and it's just going in and cross-referencing the dark and the lights with that. And so if I pull the panel down in here, right, and we pull this out, it just goes through and samples each one of those points and gets me a brightness between 0 and 1, right? And then basically we turn that into a unit z vector, so it just gives you a 0, 0, and then puts that in the z. Then we multiply that, right, and it multiplies it by 10. And then we push that into the points, those original points in the z. So we move those in the z based on this number. So if I preview this, you'll see now that those points are moving up based on the highest ones in the center and the lowest ones on the south. Now at this point we come in and we put a NURBS curve on it, right? And then, oh, this we don't need for something else. And then we can loft it, right? So now we have that loft coming in. Now the NURBS curve, if you were watching the previous, you can actually do a, you can see maybe, the NURBS curve is weighted, so you can see that the curve doesn't exactly go through the points. You could actually do the same thing with an interpolated curve, right? So let's go ahead and flatten that. There we go. So so it goes right through it. That is one thing I didn't mention, is that I did flatten it. If you don't flatten it, so let's get rid of the flatten and let's pull this into a panel. It brings each one of those curves out as a separate curve, and so it tries to loft just in one curve. Once you flatten it, it then lofts between all of those curves consecutively. So that's a little bit of a difference, but let's take a look at this. Let me go ahead and turn all that off so you can just see that. And then what I can do is I can come in and change this to a different, right? And it will make it into a different shape. So if I went and got something maybe a little less uniform, see how that does, right? Right? You start to get that. So the idea is that you have this open command string that you can replace critical parameters and really sort of update to a different shape very quickly, right? So there's that guy. All right, so the last thing, last one I wanted to show you is a sound reactor, or at least that's what I've called it. And this I learned in a workshop that was run by Andy Payne, who basically wrote Firefly. And, well, if you look him up, you'll see a lot of stuff that he's worked on in this sort of area. And so what we developed, he was just developing an idea that really all you're looking for are numbers, data, and input, and you can manipulate that any way you want. So this particular definition takes sound and translates it into z-coordinates and color. So let's take a look at that. You're going to see my computer really slow down on this one, so it's a little heavy. All right, so this one's a little bit more complex, and you're going to see it reacting to my voice a little bit, and also to the air conditioning that's in here. But basically what this definition is doing is it's going through and it's measuring the level of the input, and when the fan comes on it gets much louder. My PC, My laptop fan just came on because it's now cranking through all of this, and it's listening to my voice as well. So it comes through and gets these numbers, and we look at these numbers and start to find the sort of high and low, and you kind of try to constrain that into a range here. And then it takes these numbers and smooths them and remaps them between 0 and 20. And then you can see them sort of getting pushed out here on the other side. So it's recording them as they come in and pushing them out in groups of 9 right now, right? And so basically what you want is to have this rectangular grid match the number that you have here. And then what this rectangular grid is, right? If we preview that, you can see it right there. It's just giving us a set of points that we can deconstruct and add this into the Z, just like we did in that last one. And it creates subsets of this, and then it goes through and uses several different meshing operations to create this mesh. So one thing that's quite nice about it is that it's actually reacting to my voice, but I can also have it react to music.